Polar coordinate is actually pretty easy. A lot of people have a hard time understanding this, but I think hopefully by the end of today's lecture we'll be okay. So we have a regular x and y coordinates. Okay? We are very used to pick any point. I could figure this out by just writing by x and y, right? So here's my x coordinates. Here's my y coordinates, right? But now the polar coordinate is really asking you to change that and make a segment out of that, right? And you can measure the angle here. We'll call it theta. And we can measure how far away that point is from the center, from the origin, right? So we can notate this point using simply r and theta. That is what polar coordinate is. But just understanding that using Pythagorean theorem, that we realize that this thing is x, this thing is y, and it's a right triangle, right? So we have this special relationship that x squared plus y squared is equal to r squared. And we have more relationship. If I know r and x, and I can, if I know y as well, I can express cosine theta as, look, maybe we should go up here to make more room. I'll write this again up here. I think that's better for you. X squared plus y squared is equal to r squared. Okay, cosine theta is equal to adjacent over hypotenuse, right? So it's going to be x over r, and sine theta is equal to opposite over hypotenuse, so y over r. But we could bring that r to the other side, so we get r cosine theta is equal to x, r sine theta is equal to y. So this is how we can express x and y once we know r and theta. So these are the three things that I want you to memorize or put it in your calculator so you can always convert it, right? Okay, so we will look at some conversion problems. Let's go from example 1. Example 1 is really asking you to see that if I have something like 40 degree here, that looks like 35 degree. Okay, let's make it 35. And the radius is, let's say, 5. Okay, so I could notate using polar coordinate like that, r and theta, right? But I could notate it the other way as well. If I just think of it as, okay, what about the opposite side? Bring it over. Then my angle is 180 plus 35, which is 215. But if I am pointing 215, but the radius is negative direction, then I'll be doing the same point, right? So over here, but I am going back there by writing minus 5, angle 215. Does that make sense? So even though you came to this angle, terminal side, because you're pointing minus direction, you end up at that point. Okay, let's do one more. We could go around many, many times, but let's go the other way. If I go to the other direction like this, what is that angle? That's going to be minus 180 plus 35. Okay, so we're going to get minus 145. Okay, minus 145 degree here, but I could make it point the other way by writing minus 5 minus 145. That makes sense, right? We could do more. We could do one more by writing all the way around like this. Okay, that's going to be minus 360 plus 35, right? So this angle is hard to notate it, but I'll write over here minus 325 degree, right? Then, because I came back to the terminal side, I don't need to point the other direction, so I can still do positive 5 minus 325 degree. So all these are pointing to the same point, right? If you end up in the opposite side, you point the other direction. If you end up in the same side, you use the same length of the radius. That's all that is.